Okay, welcome back to another one. So right now we're going to quickly get through number 7 and number 8. So number 7 and number 8 in our textbook, and how to answer these types of questions. So if you looked at the question, it gives us the delta H values of a reaction, and then we need to calculate another reaction from these two. So we've got reaction 1 and reaction 2. So in reaction 1, we've got 1 half N2 plus O2 forms NO2. Let's write down the symbols: gas, gas, gas. Delta H naught is equal to negative 57 kilojoules per mole. And then let's look at number 2. Number 2, we've got N2 plus 2O2 reacts to form N2O4 gas, and our delta H naught is equal to plus 9 kilojoules per mole. And it says use these values to calculate this equation. So 2NO2 gas reacts to form N2O4 gas. And it gives us the options A, B, C, or D, which are negative 105, negative 48, plus 66, or plus 123. So let's look at this. To answer this types of question, we want this reaction, and we could only build it out of these two reactions. So it needs to be like linear combinations of these reactions. So the first thing we want to do, right? We've got N2 on the right, but here we've got N2 on the left. N2O4 on the right, N2O4 on the right. So that's what we want. So what we want to do is we want to flip this equation around. So if we flip it around, we get NO2. I'm not going to write the states right now just to save a bit of time. Forms O2 and 1 half N2. So now this value needs to flip too. So instead of negative 54, our delta H of reaction is plus 57 kilojoules per mole. And then what we're going to do is we have 2N2 here, and we need 2N2 here. So we take this whole equation, we multiply it by 2. So we've got 2NO2 reacts with 2O2 and N2, and our delta H value is equal to 114 kilojoules. And then now let's compare the two. So this is, we can get rid of this up here, but we didn't touch the second one. So that's equation 1. Equation 2, we've got N2 plus 2O2 reacts to form N2O4 with a delta H of, I'm just going to double check this value that I wrote it down right. Yeah, 9 kilojoules per mole. A delta H of 9 kilojoules per mole. So if we look at this, we can start canceling off. On the left is an N2, on the right is an N2, they're gone. On the left is an 2O2, on the right is a 2O2, they're gone. And then we've got 2NO2 reacts to form N2O4, and we just need to add these two together. So we've got delta H is equal to delta H of this reaction is equal to plus 123 kilojoules per mole. Yeah, and that's it. That's our combinations of two different enthalpies, because enthalpy, this is something that we can't forget. Enthalpy is a state function. So it doesn't matter how we get to this final product. The energy, we can still calculate the energy indirectly through different reactions. So let's do that's number 7. Let's get down to number 8. So number 7, D. And let's get down to number 8. I'll just change the color up a little bit and flip the page. Standard enthalpy change of 3 combustion reactions are given. So let's look at these reactions. We've got 1, 2, and 3. So we've got 3 different reactions. We know this one's going to be a little bit tougher than the last one. 2C2H6. So I'm copying them down. I'm not going to write down the states, but you should always write down the states. Plus 7O2 reacts to form 4CO2. And the delta H naught is equal to negative 3,120 kilojoules. Reaction number 2 is 2H2 plus O2 reacts to form 2H2O. And our delta H is equal to negative 572 kilojoules. And the last one, we've got C2H4 plus 3O2 reacts to form 2CO2 plus 2H2O. And our delta H value is equal to negative 1411. And the unknown reaction, the one that we want, is C2H6 reacts to form C2H4 plus H2. So let's see where to start with this one, right? We got C2H6 on the left. We've got C2H6 on the left here. We're pretty happy with that. Here we've got, this is the only one with H2, and we need H2 on the right because it's on the product side of the equation that we want to do. So we know we're going to have to flip this equation. So if we flip that, I'll just write it out. 2H2O reacts to form O2 plus 2H2, and our delta H value is now positive 572 kilojoules. So I can take that off. Oh no, it got too big. H2O reacts to form O2 plus 2H2. I'll go a bit slower. Okay. And the last one, we've got C2H4, and we need C2H4 reversed too. So let's reverse this equation. So here we've got 2H2O plus 2CO2 reacts to form 3O2 plus C2H4. And our value is going to be, our delta H value is going to be positive 1411 now. So let me just take this off. This is equation 3. And now let's see how we can combine them. See how we can get rid of all of this stuff. So how can we do this? We've got 7 here, we've got 3 here, and 1 here. So we can definitely make some sort of combination here. We just double this plus 1. So that could be where we want to start going. I'm just trying to figure out how these H2Os are going to cancel out. Let's see. H2O2 and H2, so the O2s need to cancel. We got them on the right and this one on the left. Good. Got H2O, though is going to be a tough one to get rid of. Because now that we flipped this equation, C2H4 is on the right, we got H2O here on the right, so we need to somehow get rid of that H2O. So this is going to be a nice, little more challenging one, but we can try to work through it either way. We got CO2 on the right here, CO2 on the left down here, but we've got 4. So let's try this out. Let's try to double up this equation. So this equation times 2. So we've got 4H2O plus 2CO2 reacts to form 3O2 or 6O2 plus 2C2H4. And our delta H value is going to be 1411 times 2. 1411 times 2 is going to be 2811 kilojoules. So let's take that off. Oh, I missed the one up here. That's why. Plus 6H2O. Yeah, there's where the H2O is going to come from. So now let's look at these equations. So we've got 6H2O on the left here, 6H2O on the right here. So we're happy with that. We've got 702, 702, we're happy with that. This one, I wrote down wrong. So this is supposed to be 4 now that I've doubled it. Because it was 2 CO2 and 2 H2O, and now we've doubled it, so I forgot to double that one. So we got 4 CO2 here, 4 CO2 here. It seems like these reactions might work, so let's just add them together and see what we come out with. So I'll rewrite this equation again at the end. So let's look, let's just add these two up. Let's add 2 and 3, 2 plus 3. So we're going to get 6H2O, 2 plus 4, plus 4 CO2, yeah, so let's keep going. Forms 7O2 plus 2H2 plus 2C2H4, and our value is going to be 572 plus 2811. Our delta H value is going to be 3383 kilojoules. And then let's look at what can cancel off. So we've got 6H2O here and 6H2O here. We're happy. 4 CO2 here and 4 CO2 here. We're happy they cancel. 7O2 and 7O2 here, and we're left with what we want. So let's do this plus 1. So plus, let's do this 2C2H6 plus 7O2 reacts to form 4 CO2 plus 6H2O. And the delta H value is negative 3120 kilojoules per mole. So let's just add them together. I'll take different colors for cancel. So 7O2 on the left, 7O2 on the right. Gone. 4 CO2 on the left, 4 CO2 on the right. Gone. 6H2O on the left, 6H2O on the right. They cancel out. And we're left with 2C2H6. Reacts to form 2H2 plus 2C2H4. And let's add these values together. Minus 3120. We get a delta H value of 263 kilojoules per mole. But then let's compare that to what they want. So the equation that they wanted was C2H6 reacts to form C2H4 plus H2. So if you see this, there's a fundamental change. We've got a 2, 2, 2, and 1, 1, 1. So we just need to divide this by 2, and we'll have our final answer. And our final answer will be delta H is equal to 131.5 kilojoules per mole. And then we're done. 131.5. Good. So we'll take a pause for this video, and we'll do another video next.